All right, today is an important lesson on the works of rivers. Rivers are always doing something. They're either going to be eroding away sediment, which is removing it, or they're going to be depositing sediment, which is leaving it in place. It's never doing nothing. There's no break for a river. It's always working. It's always doing something. I really admire rivers. So like I said, rivers can cause erosion, which is the removal of sediment. And rivers transport more sediment than any other erosional force on the planet. More than glaciers, more than the wind, more than just gravity. Rivers transport the most sediment. There are 3 different ways that rivers can transport sediment. The first one is dissolved load. And this is stuff you can't actually see in the water. It's dissolved. Kind of like when you put salt in water. It dissolves, which means it separates out those different elements, and you can't see the salt in the salt water. As rivers flow, they dissolve away minerals. And added to these rivers are groundwater, or water that's traveled over top or through rock layers. And that whole time, water's dissolving out minerals. And it brings it to a main river, which then eventually brings it to the ocean. Another way that rivers transport sediment is through suspended load. And this is sediment that's, just that perfect right size where the water is moving fast enough that it can keep that sediment from touching the bottom of the river. So it doesn't bounce off the bottom, it stays suspended or almost floating, but it's not really floating, it's not buoyancy, it's just the speed of the river keeps that material from touching the bottom. And this is what makes rivers look that muddy brown color. If you ever drive over a river, you see a river and it just looks brown, you can't see in the water at all, that's because it has a really high suspended load. The last way that a river can transport sediment is bed load. And this is material that's not quite big enough to remain stationary on the bottom of a river. But it's also, just that right size where it can't be suspended any longer. So maybe it's kind of bouncing on the river bottom. As the river's flowing, it kind of makes it bounce. Or sometimes they tumble or roll. Or sometimes they just scoot along the bottom of the river. The main idea is that they're not stationary, but they're not suspended. A couple of terms that we have to describe the amount of sediment being transported is competence and capacity. The competence of a river is the single largest particle the river can transport. And this is really tied to velocity, because the faster the water's moving, the larger the piece of sediment the river can transport. Capacity is more related to discharge. It's a volume. It's a quantity of sediment the river is capable of moving. So moving away from erosion, rivers could also lead to deposition. So deposition is leaving sediment behind. And when we talk about deposition of rivers, it's normally talking about depositional features, things that form because of the sediment left behind. One of those features are deltas. This is when a river flows into a standing body of water. So just think the Mississippi River flowing into the Gulf of Mexico. As the Mississippi flows into the Gulf of Mexico, the water slows down. When it slows down, it can no longer hold that sediment and it drops it. This sediment then begins to collect and fill up the river channel, eventually making a fan-shaped depositional feature at the mouth of a river. One thing that's important to know about deltas and just rivers in general is that they do a really good job at sorting sediment. And if you think about that river we just talked about, the Mississippi flowing into the Gulf of Mexico, the largest particles would be deposited first, the heavier things. And the smallest sediment would work its way further and further out into the Gulf of Mexico. That's sorting from biggest to smallest as a river flows into, let's say, the ocean. Part of making a delta is the formation of distributaries. So distributary is the opposite of a tributary. So you're taking one big river, like the Mississippi, and you're breaking it apart. You're distributing the water to many smaller rivers. And this process helps to distribute the sediment that would produce a delta. Another depositional feature are natural levees. A levee is a ridge of sediment that parallels or travels next to the side of a river. And it's formed just through repeated flooding. Every time a river starts to flood, the velocity speeds up, there's more water, and it carries more sediment because it's traveling fast. But as soon as that river starts to flood, the water spills out of the channel and it slows down. When it slows down, there's some instant deposition that takes place. And over repeated flooding, this instant deposition on the very top of a stream channel ends up producing these little banks, these little piles of sediment that collect over time. They grow bigger and bigger with every flood, and those are natural levees. There's some really good things about levees too. It means that flooding doesn't occur as often. But for every good thing, there's a bad thing. And one of the negative sides of natural levees is that if a flood does occur, water would spill over the levee, and the levee actually traps it on the floodplain. Without a levee, water on a floodplain would just very quickly, through runoff over the surface, enter back into the stream channel. But these big piles of sediment, they prevent runoff back into the river. So it traps the water on the floodplain. That's it for the works of streams. It's either going to be erosion or deposition. Please make sure you have some really good notes and make sure you're asking questions when they come up. Thanks.